All right.
It's not like actually a song.
Moving on to 7.2 today. 7.1 talks about all polygons, right? So we have any polygon. We could have triangle, rectangle, we could have anything. Today we're going to kind of move in to talk about more specific types of polygons, and today we're going to get into parallelograms. And what we're going to find out about all these different polygons is a lot of them have different properties and different things. And so if I have a statement that says this is a parallelogram, then the fact that we know that it's a parallelogram, then we'll know some things about it. Okay, so today we're going to talk about some of those properties, and we'll continue on to tomorrow. We're going to do 2 days of 7.2 because there's a lot of stuff in here we're going to talk about. Now, here's what I will tell you is because this is still a polygon, all of the rules are still true here, right? So a parallelogram is a quadrilateral. So what do we know about a parallelogram? Well, how many degrees would it have on the inside of it? 360, okay, every time, okay? So we still know those things. Those things are not disappearing, right? We know because it's four-sided, it'll have 360 degrees. Then we'll get into some more specific things about it based on some other things that we might know about it. But the very first thing up here is the definition of a parallelogram. A parallelogram is a quadrilateral, which means it has four sides, with both pairs of opposite sides parallel. Okay? And so immediately here, we see that we have four sides. We see that these two are parallel. We see these two are parallel. Okay? And that's given to us here. So that's what makes this a parallelogram. If we know this is a parallelogram, or if they give this to us that these sides are parallel, then we can go on and we can confirm some other things about this figure. These are the first two things that we're going to talk about. Notice that this is an if-then form. Okay, it's one of those if-then statements that we've talked about throughout the year. We've seen this all along. If this happens, then this happens. So first of all, the figure has to be a parallelogram. Okay, so they're telling me that it's a parallelogram. So if we know that this is a parallelogram, then one thing that will always be true is opposite sides are congruent. So we know that QR and PS are congruent. We know that RS and PQ are congruent. Hey.
Yeah, I just got switched in.
Got switched in here. Okay. That'll work. You can sit there. Do you have a notebook?
Yeah.
Okay. So not only are these sides parallel, but they're also congruent, and same thing for the top and bottom. Okay? So we have two pairs of sides that are parallel and congruent at the same time. And those are two completely different statements, right? So we know they're parallel, we also know they're congruent. Down here, if the figure is a parallelogram, then opposite angles. Opposite means they're across from one another. So Q and S are congruent, P and R are congruent. So right now we don't know the measure of those angles, but we know that these two are congruent, and we know these two are congruent. Okay? And here's what I'm going to tell you about angles especially. If I tell you that this angle here is 110, we know that this is a parallelogram. And so think about some of the things that we've talked about throughout the year. Okay? If this side and this side are parallel, what kind of angles are these two right here? What would we call those two? What kind of pair is that? Q and P. Think about parallel lines, and what name would we use for P and Q? Same side interior. Good. Yeah, because they're on the same side and they're both on the inside of these two parallel lines. And what was true about same side interior angles way back when we talked about them?
They equal 180.
They equal 180, yeah. So if this is 110, we know this is 70, okay? And now, based off of what we just said, if this is 70, we know R is 70, and we know S is 110. So if I know this is a parallelogram, and all I would only really need to know is one angle, I could find the other three angles pretty quickly, okay? These two are gonna be congruent to one another, these two are congruent to one another, these two make 180, these two make 180, okay? And that'll always be true. Also notice how these make 180 as well, because these two are parallel, these are also same side interior, okay? So it works whichever way you wanna look at it. That's one thing we're gonna spend a lot of time with today is identifying the parts that are congruent and then using that to find missing information. So on this first example here, we try to find the values of x and y. So really pay attention to if it's a side or an angle, and I know in this case that we're really just saying that they're congruent, but x plus 4 is a side, 12 is a side. These two sides are across from one another, right? So we know that AB is congruent to DC. And because those two sides are congruent, then I could say that AB is really x plus 4, and DC is really 12. So we're going to set those two sides equal to one another. Okay, once we have that set up, is that a hard equation to solve? Should be a piece of cake, right? One-step equation, subtract 4, and we get x equals 8. And that's what it wants to know. What is the value of x? So we got to get the equation set up. Make sure you set up the right pieces. Okay, for my angle, up above, we said opposite angles are congruent. So I could also say D and B are congruent, but we don't know either D or B, so we don't really, that's not going to really help us a whole lot here. We're not doing anything with D and B. A and C are the ones that have angles labeled there. So if A and C are congruent, then that means Y must be 65. And that's all there is to it, okay? Sides are congruent, angles are congruent. Here we don't have an X and a Y, so they ask us a little bit differently. Remember that if they say FG, if there's nothing above FG, what are we really asking? Distance, right? What is the distance from F to G? Or what is the length of FG? A lot of different ways we could say that. We're not trying to find X, we're just trying to find out what is the length of this side. It's the same as the side across from it. So if HE is 8, then FG would be 8. Pretty straightforward, not a whole lot of work to be done. Okay, if angle E is 60, now just be really careful here, okay? Angle G is across from it, so as long as it's across from it, then we know that angle G is equal to angle E, so angle G would also be 60 degrees. Once again, not really any work that needs to be done there. Where it gets a little bit more difficult is when they start throwing expressions in there and you have to solve. In this case, once again, kind of like the first one we did, we have to solve for X and Y. So in this case, let's do sides first. Opposite sides are going to be congruent. It doesn't matter if you say 18 equals Y plus 3 or Y plus 3 equals 18. It doesn't matter what side it's on. But it does make a difference which two you set equal to each other. The two sides are equal to one another, so 18 equals Y plus 3. We try to solve for Y. We subtract 3, and we get Y equals 15. Now remember that Y is the value of a variable. It is not a length of a side. So if you wanted to check this, I could take 15 and plug it back in here. 15 plus 3 is 18, and then that kind of checks your answer a little bit. Okay, same thing for the angles. We know that angle J is congruent to angle L because those two are across from one another, right? They're opposite of one another. So angle J is 2x. Angle L is 50. So then we divide by 2, and we get x equals 25. So when I solve for x or y, I don't need to put a label on here. I don't need to put degrees or feet or anything like that because we're just finding the value of the variable. We're not trying to find angle measure or anything like that. Okay, now I already talked about this, but we'll talk about it here as well because we got a picture here. We talked about if we have a parallelogram, not only our opposite angles are congruent, but we called these two consecutive interior angles, or same side interior angles. There's a couple different words or names that we used for it. And what we said was, if these two lines are parallel, x and y would be supplementary. So we know that x plus y would equal 180. And so we're going to see that a lot today because when we have a parallelogram, we're going to have consecutive interior angles a lot. And it could be these two angles here. It could be these two angles here. Both of those are consecutive interior angles. So we have a couple of different pairs of consecutive interior angles. We already kind of did an example like this. But if I tell you that this is a parallelogram, and I mark those sides as being parallel to one another, then if this is 80, then what's the angle across from it have to be? It'd be 80 also, right? Because opposite angles are congruent. Okay, these two angles, or these two angles, are going to be consecutive interior angles. And so these two would have to add up to be 180. These two have to add up to be 180. So that means both of these would then have to be 100. Okay, so we have several different pairs of consecutive interior angles. And we have actually 4 different pairs. We have these two, we have these two, we have these two, and we have these two. All of them add up to be 180. Okay, and so there's a lot of different relationships going on there. So here's the next two theorems. This one we've already talked about. Consecutive interior angles make 180. As long as this is a parallelogram, then x plus y. And you say, well, which x and y are they talking about? Any of them, right? Because these two, these two, these two, or these two all add up to be 180. So we have 4 different pairs we could add up to be 180. X and y are the same value in all locations. Okay, here's the 4th theorem for today. We got lots of theorems, lots of information going on, but pretty basic information. Okay, on this first one here, this one does not talk about congruent sides or angles. This one talks about the diagonals of a parallelogram. So a diagonal goes across a parallelogram. So here we have QS, here we have PR, right? It goes from one corner to the opposite corner. So we have 2 diagonals in this parallelogram. And what it's saying is that if we have a parallelogram, the diagonals will bisect each other. Well, we've heard that word bisect before. Bisect means to do what? It means to split in half, right? And so what we need to make sure we understand here is all 4 of these are not the same. If I tell you that this piece here is 4, then this piece here would be 4. If I tell you that PM is 6, then RN would be 6. So the diagonal is split in half, but not all 4 of these pieces are the same. Okay? They're bisected. So PR is cut in half. 6 this half and 6 on this half. QS is cut in half. So the diagonals are splitting each other in half. Okay? A lot of people think all 4 of these measurements are the same, and that's not the case. Okay? So you got to be careful about that. QM and SM are congruent. I used a number to kind of represent that, and then PM and RM are congruent. And I used 6 to represent that. Okay, this one, we're using the parallelogram properties to kind of come up with an idea of what's going on. This one, it's kind of hard to see the picture, especially in yours is black and white, but we're talking about this parallelogram right here that's in red. It's the arm of that lamp that we got. If you needed to, you could redraw the picture. Kind of looks like that just to make it a little bit bigger. A, B, C, D. It says angle D is 110. And as long as, they already told me that this is a parallelogram, okay? So we don't have to prove that it's a parallelogram. That's coming, right? Where we have to do a little bit of proving. Everybody's excited about that one. But we already know this is a parallelogram, okay? Because they tell us it's a parallelogram. So if D is 110, then what would C have to be? It'd have to be 70, right? So you only have two options today. If it's across from it, then it's equal. B and D are going to be the same thing. If it's on the same side or same side interior, then they're going to be supplementary. So all we got to do is take 180 minus 110, and that leaves me 70 degrees. Okay? So really be careful about the placement and where that angle is at. That's why I feel like redrawing that picture is maybe a little bit better, because it's kind of hard to see in the picture that they have labeled up there. Okay, on this one, it says part of the extending arm of a desk lamp is a parallelogram. The angles of the parallelogram change as the lamp is raised. So as they kind of change this pivot point, it changes the angle of the lamp a little bit to put it in a little bit different location. Find the measure of angle C and D is twice the measure. Okay, so first of all, C and D, okay? Find measure angle C when D is twice the measure of angle C. So first of all, what we just said, what's the relationship between C and D? What do I know about C and D? It equals 180. Okay, so here's what I'm going to do. I'm going to say angle C plus angle D equals 180. Those two angles together make 180 degrees, right? We just talked about that on the last problem. But now we're going to do a little bit of algebra to help us with this. It said, find C when D is twice the measure of angle C. So I'm going to say angle C is X. We don't know it, right? We're going to use some variable for it. You can use whatever variable you want. X is the most common variable we typically use. We don't know it, so if we don't know something, we use a variable. Okay? For D, what do we know about D? What's it say about D? It's twice that, okay? So if C is X, what can I use as an expression for D? 2X, it's double. And then we do a little bit of substitution. Angle C is really X. So I put X in for angle C. Angle D is really 2X. So 1x plus 2x equals 180. Okay, what happens if I add 1x and 2x together? You get 3x. And then we divide by 3, and we get x equals 60. Okay, so that means angle C is 60 degrees. So then what would angle D have to be? $120, okay? Okay, how would we know that this really does work and that it makes sense? What do we know about those two angles? What do they have to do? They have to equal 180, okay? So two things need to be true here. This has to be twice as big, which it is, and these two have to add up to be 180, which they do. Okay, so that's how you could kind of check yourself at the end. Does it really make sense? And in this case, it works. Okay, so you got to be kind of careful with how you set that up. All right, on this one here, we haven't done one of these for a little while, right? But we're going to do a 2-column proof here. And one of the things that we always want to identify is, what are we trying to solve for? We're trying to solve that B and F are congruent. Well, right now, B and F are on two different parallelograms. So we can't just look at it and say, oh, I know B and F are congruent. Okay, if I said, prove that B and D are congruent, then we could say because they're opposite angles, right? And we know that it's a parallelogram. Same thing I could do for D and F. But we're going to kind of use that information to help us out a little bit. So, very first step in our proof is always restate the given. ABCD and GDEF are parallelograms. And what we do is just say that that's given. Okay, first step we always do in a proof is our given step. Okay, now we want to kind of come up with a plan here, right? We kind of want to come up with a plan with what we know and where we can use that to help us get to where we want to be, and we want to prove that B and F are congruent. Okay, one of the things that we've talked about throughout the semester, last semester, and throughout the year so far is a lot of times when we have pictures like this, especially when I have two pictures sitting right next to one another, what's one piece of information that I can use without having that information provided to me? A lot of times last semester we would see it written or drawn like this. We saw it more with triangles like that. What piece of information in those two triangles could we always say is congruent? Vertical angles, you bet, right? We always said, hey, this angle and this angle are congruent because they're vertical angles. And that's something I can use here as well. And I'm going to use that because we're talking about an angle on this parallelogram and an angle on this parallelogram. We're going to use it, right? And so that's going to be one of my first things here. Is I'm going to say angle. Now I can't just call this angle D, right? What would I call this angle right here? Yeah, I could either go CDA or ADC, but you got to use three letters. And so I'm going to call it angle ADC. Is congruent to angle. And same thing for the one on the other side. We can either call it EDG or GDE. Because we've talked about that before. They're still right across from one another, so we know these two angles are congruent because they're vertical angles. Okay, now where that helps me is if I look at this parallelogram, what angle would be congruent to angle D? Angle B, right? Because what we just talked about today is we already know that this is a parallelogram, right? And we know angle D now, and we know D and B are congruent. Okay, so what I can say here is that angle B is congruent to angle ADC. So I'm going to mark it. Over here, what angle would be congruent to angle D? Angle F. And on this one, I don't need to use three letters because there's only one angle at B and F, right? I don't need to use three letters because there's not more than one angle there. So I can say angle F is congruent to angle EDG. So you could say the parallelogram opposite angles theorem, but as I told you guys last semester, I feel like, just stating what's going on. The opposite angles in a parallelogram are congruent. If we know it's a parallelogram, opposite angles are congruent. That's a theorem. And so you can either state it as a theorem or you can just simply state what the theorem says. It's probably easier to state what the theorem says rather than trying to remember what the name of the theorem is. Okay. So now we know, really, that all four of these angles are congruent. They're all the same. We don't know the measure of them, but we know they're all the same. And so my last step, we're trying to prove that B and F are congruent. what would be my reasoning for step 4? What do you think? Transitive property would be good. Okay, I would go with transitive property. What else could I use? Would be one other thing I could probably use here.
Definition of congruency.
Close, but not quite. Hey, what I could do is I could take this and plug it in to here because this and this are the same, or I could take this and plug it into here. So I could substitute that in there. And so transitive probably would work the best because that's probably the one that we've used the most, the transitive property of congruency. Or I could use substitution property, where I could substitute this angle into that angle to show their congruence. So either one of those would be good. Okay. Assignment should be up.